Welcome back. We're going to finish up the segments with the viable piece of the stack. So we'll talk about traditional pieces of IT are more in this space, encryption, disaster recovery, things like that. So for you guys, when we're talking about viability and I talk about traditional IT, what do you think of when I say traditional IT?
Server, storage, network.
Yep, exactly. So in the AV2 category, this part here, viability, is where most of traditional IT fits. Doesn't make it any less important. It's probably the fundamental piece of it. It's the whole thing about all this software as a service and software-defined networking and cloud is really cool stuff. But as one of my colleagues back at Arrow says, you can't run software on software. So until they figure that out, there will always be infrastructure.
Right.
And that infrastructure has to be viable, meaning, do you trust it? Do you know where it's at? Is it up and running? When you put data on it, can you get it back? Is it the same data you put on there? And what happens in case of an emergency, right? So we talk about encryption, and we've all seen that. I think there's news on the wire today that unfortunately our military had unsecured drives that went out, and if you plug them in, they can get access to them because they weren't encrypted.
Not good.
Yeah, things that are bad for $1,000, Alex. We've seen records, the VA nurses that had laptops in the back of the cars that got broken into, and there's millions of unsecured records on laptops. This would be bad as well. You guys know what encryption is when we talk about encryption. Do you know what that actually means, what encryption really is?
Isn't it kind of like a code tied to it?
Exactly. So encryption, its basic form is we're changing data, we're securing data with some sort of a key phrase or a code or a password of something of that type, right? When we were kids, did you ever do the secret codes, or you would replace your letters?
Yep.
So encryption is much the same way, right? I mean, that's a simple replacement cipher. If you replace A for B and B for C, etc., that's a shifted cipher. Encryption works in much the same way, that we're using long prime numbers or the product of two prime numbers to transform your data into an encrypted thing, right? And that's the trick, right? It's easy to encrypt. It's very difficult to decrypt without having the key. And that's kind of the whole premise there, right? So when you talk about encryption, like they're about 128-bit key encryption, your encryption key is 128 bits long. Now there's 256-bit encryption. There are even things out there, 2048-bit and 4096-bit encryption.
Wow.
Take a little bit of work to...
Exactly. So to that point with today, so it's 2017 if you're watching this in the future, which would be cool. It would take, in our computer capacity today, to break a 4096-bit cipher would take literally 100,000 years or more at today's computing power to break one of those ciphers.
Wow.
Which is why encryption's great. You have to have that key. Now, if you can crack it or you get the key or somehow beat that, obviously you can decrypt all of the things. And there would be people that would say that there are certain three-letter agencies in our government that can do those things, but that's a different video on a different YouTube channel. But we do talk about things like encryption when it goes onto our storage arrays, right? So why do we encrypt things like that? First, security is the big thing. When they go onto a disk array, you want things encrypted. So if they are stolen or lost, that they can be protected. When we do, unfortunately, have to get rid of employees, that any data they might have with them can be secured. If I do have a laptop out in the big bad world, that if it is stolen or lost, that somebody can't just power it up and use it. Because the thing to remember is that even if I've got your laptop and I don't have your credentials, I can actually physically take the drive out of your computer, plug it into something else, and read that data if it's unencrypted. I don't need your password. I can actually read it just as a flash drive. If I plug in a flash drive, it's not encrypted, it's just a flash drive, right? So encrypt all the things. If there's one thing you take away, encrypt all the things. We also talk about replication as a viability thing. So in larger offices, you replicate your data from one site to the next, right? So in case of a disaster, if there's a fire, flood, where your building is physically gone, where is that data replicated? Or even on large mission critical applications like we talked about, I want to replicate my database from one server to the next. So if that server falls over, I have it somewhere else. And I do like to say, and it's only money, how fast you want that replicated is a function of money. If you want to be completely always in sync with each other, it's going to take a little more money. If it's one of those things where you snapshot it every day, every 12 hours, things like that, that's your acceptable appetite for risk, as we talked about earlier, some of the strategy stuff.
Right.
That's how you determine those things. Excuse me. We also have things, business continuity, disaster recovery. You've seen
Right.
those things. So business continuity, disaster recovery, you'll see those together a lot. Same kind of thing. What is my return to operation? So, you know, if the building is hit by a meteor, or, you know, dinosaurs come back and rampage, you know, a la Jurassic Park, how do we return to operation on that? Where do I have it physically located?
Right.
So we talk about hot sites, cold sites. You guys familiar with all those things? You heard those
I
things?
haven't actually heard of that.
So we talk hot site, cold site. So a hot site means that if, like for example in Denver, we've got multiple buildings around our campus right now. If building 1 were to fall over, if building 2 could take over immediately, that's a hot site. So they're always ready. Each other, they're either always active, like we talk about things
Yep.
like active, passive.
Right.
Mhm.
Disaster recovery, business continuity, we'll talk about hot sites, cold sites. So a hot site means, boom, I can take it over right away. A warm site is actually in the middle. So a warm site means that I have equipment staged, I may even have some personnel there, but it's not always running in sync with my other location. I've got stuff there. Cold site means that I've got facilities, I may have power there, but I probably don't have my infrastructure there, and I don't have people and personnel. It's going to take time to bring it up, you know, running out of, you know, I've got to bring personnel, and I got to bring servers, and I got to bring software, and I got to get it up and running. So it's got to come from cold to hot, you know, like a motor. That's kind of how that goes. Business continuity is on that same thing, is more from a personnel standpoint. Like if we have a storm in Denver, we can't get to work, you know, and nobody can get to the office. How does business continue? You know, how do you communicate that? And there's a lot of planning that goes into that. It was about 4 or 5 years ago, the Southeast got hit with that massive ice storm. You know, Atlanta was like offline for like 3 days. You know, we had folks that couldn't get to the office for 12 hours. And so from a business continuity standpoint, how does the other areas of the business absorb those functions? You know, that's a viability thing. How do they get to that data? So if no one can get to the Atlanta office, if Alpharetta's out of power because they, you know, all the lines are iced over, it's not really a disaster situation because we know we're going to get the building back online. We just can't get to it. So that's more of a business continuity standpoint. So we talk about that.
Okay.
That's kind of at an infrastructure level. From a viability standpoint, the other thing we want to look at, especially in today's world, is, so I've got this data, it goes somewhere, and this goes back to the security bent where we all kind of live, is do I trust that data? You know, so once it goes on a disk onto an array, it's encrypted, that's awesome. But then when I pull it back, is that the same data? So you'll hear me talk about like integrity monitoring, malware defense, and things like that of how do I know I trust that data, right? So there's things like, you know, I've talked about cryptographic hashes, MD5 sums, there's cloud intelligence stuff like Palo Alto Networks has Wildfire, you'll hear things like Threat Seeker, the Global Threat Intelligence. Everybody's got their cloud intelligence, you know, it's whatever name they want to put on it. But it's to verify, hey, when I see a file come into my network, do I know that that's what that is? If there's a process running on my Windows machine, do I actually trust is what that is? That's a big vector for malware, is that they'll attach to a process that looks like it should be. You know, Windows runs a big process called Explorer EXE, if you're familiar with it. If you ever done Control-Alt-Delete, you see Explorer EXE running. Well, Explorer is actually the shell, right? So it is what drives your desktop. It's what drives the Windows. You know, like if you remember, you open Windows Explorer, what paints the windows with all your folders, that's the Explorer process, right? Well, Explorer is a big part of Windows. So inherently, we look at it, so okay, Explorer EXE runs all the time, right? So I trust Explorer EXE. The issue is if I can attach bad malware to that, if I can attach things to Explorer EXE and spawn other processes or start sending data out, how do I know I can trust Explorer EXE? That comes into viability. So we do what are called signatures, and so like when your antivirus scanners run or some of this new malware scan runs, it looks at Explorer EXE and it says, are you really who you say you are? Microsoft says you should look like this, and they'll do there's a cryptographic hash they'll run on it that says you should get this number, you know, as a response, or this return as a response from that algorithm. It's a signature, it's a digital signature per se.
Okay.
If I don't match that, I'm probably not going to trust you. Then you can do things like we call it host integrity, and if you've been around, there's things out there that do host integrity. Tripwire has been in the space for a long time on that. Cisco has some things. Deep Freeze is one of them. That especially when I put stuff into like production environments, think web server farms, think websites that sit on the internet, things that have a lot of customer traffic on them. Primarily, I'm going to put on web servers and database servers and 3-tier applications. Those machines, once they get put into production, they get locked and they don't get changed very often, if at all, right? So with integrity monitoring, if all of a sudden I get some ping at 2:30 in the afternoon on a Thursday that, user Kay Lamerson is making a change to my public-facing web server, I'm probably going to wonder, what are you doing on a Thursday afternoon poking at my production web server? Or why did that change? Should that have changed?
Right.
And so there are things we look at that should never change. Explore EXE on those machines should never change, right? If it does change, I'm hoping it's on the second Tuesday of the month, because that's Patch Tuesday for Microsoft, and so that more than likely is going to be what that happens. If I just start getting that, hey, this changed, something changed, I want to look at it. You can't scan everything, by nature of computers and the data, things change, right? So you can't do integrity monitoring like on Word docs or pictures or things like that, because they change, right? That's kind of the nature of them. But things like command exe to command shells, things like that, those things we look at to make sure that they can't be changed.
Okay.
Does that make sense?
It
Yeah.
does.
Yeah, so all those things tie together. So kind of wrapping up that whole thing about AV2, you got to have your stuff be available to the right people. The data's got to be available, whether that's uptime from the network, access via authentication, IAM, things like that. That's availability. Visibility. What were some of the things we had in visibility? Give me a good example of visibility. Pop quiz.
So what am I doing, and when am I doing it?
Yep.
And where am I going on the network?
Right.
So essentially the what and the where and the when
Exactly.
of what I'm doing.
Yep.
So that's visibility.
What were some of the categories in visibility? Do you remember?
Like DLP.
Yep, exactly. So where would you use DLP? What would be a good use case for DLP? So this is where I get to ask some questions.
I don't like this part as much.
So data protection loss is trying to figure out where, as we're shipping something out, what is it? Are we losing data? Did we put? Are we sending out a file of our customer's credit card information? So really, just making sure that we don't lose or send out data that we shouldn't be sending out.
Exactly right. So when you talk about it, you can see where it's better to have a strategy to start with on these things than saying, hey, I got this box, I'm gonna buy a box. It's a really cool box, it does some cool stuff. I get that, and it's fun to do that, and all of our suppliers have really cool stuff, and they also have really cool boxes, and they'll do really cool things. But not everything fits everybody. So that's why I talk back to having a strategy, as we talked about earlier on the segments. How do you approach this? So, what your question, what does a successful VAR look like? It's taking these pieces we've talked about and applying it to either the verticals that they work in. If they are, there are some of you VARs out there that are specific to your verticals, right? There are customers that, hey, I work with Fed and I work with Fed banking. That's a very niche kind of thing, right? Or I'm in the energy segment. All right, so energy companies, they don't care as much about energy companies don't care as much about HIPAA, right? They don't worry about health information, privacy, portability. They worry about things like NERC and FERC, so things like that. And yes, those acronyms. Those are real.
What is that?
Those are real acronyms. The National Energy Resource Commission and the Federal Energy Resource Commission.
Okay, all right.
So NERC and FERC for the energy companies.
I like it.
Obviously, retail, we're talking more there around PCI DSS, credit card information, things like that. Hospitals, clinics, obviously that's HIPAA, right?
Yeah, right.
Healthcare Information, Portability and Privacy Act, that's the big one there. But hospitals also can be under PCI, because if they take credit cards for payments rendered, they have to worry about PCI.
Right.
So what happens is if you back some of this up, because what you'll find out, and it happens invariably, you'll get a new CISO or a new CTO and they say, I have to be compliant with everything. All of it, I need to be PCI compliant. Well, why? Well, because they told me I had to. Well, do you take credit cards? Well, no. Do you take any sort of payment information? Well, no. They're a good baseline to start from. So where it kind of goes back to is ask more of those questions about what's the project look like? As we talked about the top of the pyramid, what's the initiative, right? Is it, hey, we're doing electronic document capture at a hospital, or we're rolling out VDI across all of our infrastructure? All right, well, why are you doing that? Well, because why wouldn't we? Well, is it were the desktops old? Do you have more of a geographically dispersed organization? Oh yeah, totally. Well, how are you looking at securing access to those things? what do you mean? We have firewall. Yeah, but now you got guys that are outside the firewall. You got, girls that are logging in from Kazakhstan. I can pick on Kazakhstan for whatever reason. How do we know that we can trust that information? When that data lands on the network, how do we know who has access to it? Where does it go, right? How are you securing it? How are you isolating it? Should you be able to see her stuff? Should you be able to see my stuff? Have that plan going forward on that. Once you find those things, then it becomes that, all right, and then once we have it, how do we know we can trust it? Where does it land? Is it on this array? Is it on that array? Is that business critical data, or is it just nice to have data? And are we collecting it and building an entire picture of the network? So then it comes into that whole strategy thing. So successful VARs actually slow it down a little bit. Instead of saying, I got this cool new thing, it's really awesome. You'll get to that point, but it actually step back and build out a 5-year plan with them. Talk about a security strategy. What does that look like? What is your risk profile? What's your appetite for risk? And then what's your budget? I mean, that's a typical sales tactic, but it is interesting to know, what's your budget? Because that would help drive that too. If they got, hey, I got $1,000 or $100,000, whatever it is, and I got these problems. Maybe none of this is viable. You don't need visibility. You have a serious problem with patch management and even understanding where your assets are. So you might have to slow down the sales cycle, which I know every salesperson that's listening to this just decided they wanted to throttle me. But you'll actually build more of that consultative advisor role, which is where we see a whole lot more success.